After combining my skills in web development with my skills in robotics and embedded programming with my ESP32 projects, I returned to Python, my first programming language, to learn computer vision and eventually build this face recognition app. Before building this, I took some time to learn computer vision fundamentals with opencv, making a bunch of projects you can see on this GitHub repo. This facial recognition system builds directly on the computer vision foundation I established doing so. I developed skills in opencv operations, real-time video processing, and working with images as matrix datasets. Those projects taught me camera calibration, color space conversion, contour detection, and interactive UI creation, all essential groundwork for this more advanced application. This Python application combines face detection techniques with file system management to create a real-time facial recognition system. It captures live webcam video, detects faces, and identifies individuals by comparing face encodings against stored data, displaying recognized faces with labeled rectangles showing each individual's name. The system implements real-time facial recognition through several integrated components. Using opencv, a hard cascade XML classifier detects faces in each video frame and provides precise bounding boxes around facial regions. But this only detects faces and does not recognize individual faces. Once a face is detected, the application generates a 128-dimensional face embedding using deep learning-powered encoding, creating a unique numerical representation of each person's facial features. This system compares these face encodings from the live video feed against a library of known face encodings. During the setup, the training pipeline uses file system traversal to automatically load images from a designated directory, converting each photo into a face encoding for comparison. New faces can be added by pressing I and positioning your face in the box that appears. This captures an image that is added to the training file, allowing the system to remember the face even after the program ends or the computer is turned off. So I'm just going to give you a quick demo of what the project actually looks like. So you run the file. To start it, you type in !, and then it trains on the stored faces, which is just an image of a face that's in the stored faces directory. And now whatever images are in that directory, it stores it and makes an encoding of that picture. So if it detects it in the live video, like it will now with my face, it'll say my name. It only has a picture of me. It doesn't have a picture of my sister here. And that's where the other feature comes in. So I can click I and then get her face in this rectangle. And then after 3 seconds, it'll ask me inside of the terminal to give her a name. Her name is Serenity. So once I type in Serenity, now it identifies her name as well. And as you can see inside of the stored faces, it added the picture that I just took of her. So the next time this program boots up, it'll still remember her. So this is the actual program. It's written in Python and it's about 114 lines. So at the top, I just import the necessary libraries. The OS library allows me to traverse the file system. The time library allows me to do the time sequence during the enrollment. This is importing opencv, and this is the face recognition library, but it's built using CMake and dlib. I have some global variables. The first one is the actual training file where I store the faces. The second is the known encodings, and then the known names, and these correlate, so the encodings correlate to the name. At index 0, if you have a face, that name will be index 0. Now the start question is just a prompt to start the program with the same thing for the key. The font is just the font that I'm using for the windows and when I write on each image. The camera width and the height is like how big the image is or the resolution, and then this is the string for the window because it requires a string. And then this is the hard cascade, which detects the faces, but it doesn't recognize the faces like the face recognition library. This function just trains on the faces in the file path, so it takes the path and then known faces and known names, and it basically, for each image inside of the path, it just takes, this is the path, and then it gets the name by taking the text and splitting the file. So it's just like a folder full of JPEGs. This would be the directory that is doing this too, and you can have however many images with faces, and then it will take the file name, and that's the name of the person that's displaying. So after loading the image in the file, it loads the image into the face recognition, and then it creates an encoding of the face from the picture in the file system. After doing that, it appends the known encoding of the face to the known faces array, and then the name that correlates to the face in the file, and then known names. This just defines the camera height and width. This just sets the FPS of the camera, and this returns a frame from the camera. This returns a flag saying if it's true or not, and then this is the actual matrix or the image. So this starts the program, and then if the start input is equal to the start key, then it runs training faces, so it trains on each faces in the file path, and then appends them to the known encodings and known names. This defines the camera. This sets the camera to be motion JPEG, the size of the camera, and this sets the FPS. And then this creates the window where we display our frames with that empty string from earlier. So while true, which basically just runs after you enter the key, it takes a frame from the camera, and it's an unknown face. It converts this frame that it got from the camera from BGR or blue, green, red to RGB, because opencv works in BGR, but the face recognition works in RGB. So then it gets the face locations, so basically where each faces are of the unknown face, and then it compares, and then it gets the face encodings. So basically it detects the face, gets the location, and then it gets the encodings from the face location, and then it converts that frame back into BGR to be displayed. So this basically just checks for each face location and the unknown encodings, and then it basically gets the location into these variables. It also prints out the face location, and then it draws a rectangle around the position data that you get from that face location that we just got right here, which is basically the top, right, bottom, and left. And then it draws it, and remember, this is BDR, so 0 blue, 0 green, and then a full red, and then this is just like the thickness, I'm pretty sure. And then it gives it a name of an unknown person. But we check matches by comparing the faces of the known encodings with the unknown encodings that we just made right here. And if the match is true, then we create a match index, and then we print the match index is true. And then we make a name from the known names, which is the match index, which is basically, like I said, inside of the known encodings, it correlates to the name. So whatever index matches, you can plug into the known names to get the same name that matches that face encoding. And then we put the text on the unknown face, but we put the known name, and then we basically just draw it where it is. And then we finally display with the I'm show that unknown face frame. But now it's identified if there is a face or if not. And this checks for all faces inside of each frame. So, and then this is when you enter in a new person. So it basically waits, and then if a key is pressed, if the I key is pressed, it inspects the frame. It starts a wait time, and the wait time is 3 seconds. It starts a timer, and then it gets another frame from the camera. It draws a rectangle around this frame. That's the region of interest, or ROI, is a rectangle that you just drew on the frame, and then it converts that ROI into grayscale, so there's less numbers in the matrix, basically, to make it simpler for the hard cascade to process it and detect if there is a face. So basically, after it detects the gray frame for the face, it ends the time that we just took, and then it checks from the faces that we just detect using the hard cascade. And if there is no face, or if it's equal to 0, it tells you to put a face inside of the rectangle that is displaying. And else, that means there is a face. It starts subtracting the time from the timer, basically having the face in that rectangle for 3 seconds to get a steady picture. And then creates the ROI into RGB, blah, blah, blah. It gets a face encoding from that. Then it appends that into known encodings, blah, blah, blah. It appends the face, blah, blah, blah. It gets the name from right here, where we get the name input after the timer goes off, which you saw in the demo. It writes the image, blah, 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 and it joins the path to the file system. So it plugs it into the file system for later training. So the next time that you boot the program up, it'll remember the faces that you implement from the live video feed instead of just the stored data and the stored faces. This is just text on the frame for counting down. This actually finally shows the frame. This checks if you want to quit the identification, and to get out of that mode, you just click K. And then this checks if you want to quit the whole program, and to get out of that, it just checks the keyboard for if you're pressing Q, and then it press quit, and it breaks. Some challenges overcome during this project were processing high-resolution frames in real time without dropping FPS, which FPS did significantly drop, and if I did this now, I would do multi-threaded programming. Another challenge was resizing the frames for detection, then scaling the coordinates back, and also managing multiple faces in a single frame with proper identification, and finally creating an enrollment process that also validates the image quality by detecting if a face is in the square. Some skills developed were real-time computer vision pipeline design and optimization, face encoding management and matching logic, integration of deep learning face embedding techniques, user interface design for interactive enrollment, biometric data handling and processing, matrix manipulation, and feature extraction from a matrix. This face recognition project represents a significant milestone in my development journey. This project not only demonstrates technical growth in Python and computer vision, but also the ability to create practical, user-friendly applications that bridge the gap between complex algorithms and everyday functionality.